Welcome to today's lesson 4.7, which talks about inverse trig functions. To understand the inverse sine function, we have to look at the graph of the sine of x. And remember, in order for a function to have an inverse, it has to do what? And if you answered past the horizontal line test, you would be correct. So if we look at the sine function as a whole, notice if we drew a horizontal line, that it does not pass the horizontal line test, which means in order to have an inverse, we have to basically restrict the domain, meaning we only have to look at a certain part of the graph in order for the sine to have an inverse. So we're just going to look at part of the graph. And basically, in order to do that, we want to have one continuous piece of the graph. What I mean by that is we don't want to look at like this part from here to here and then this part over here. All right, we want to look at one continuous part of the graph. And in order for the sine to have an inverse, the continuous part that we will look at, and that's why I extended the graph out into the negative quadrant, it's over here, into the negative axis, is the part between, if you look at it between negative pi over 2 and positive pi over 2, it would pass the horizontal line test. Whereas if I looked at it from any other parts that I drew here, it wouldn't pass. All right, so basically the inverse has a domain that is restricted to between negative pi over 2 and positive pi over 2. If you think about it in terms of quadrants, like 0, pi over 2, pi, 3 pi over 2, negative pi over 2 is the same as 3 pi over 2. So if we say it exists between negative pi over 2 and positive pi over 2, we're saying basically the sine inverse exists in the fourth quadrant and in the first quadrant. All right, so basically the sine inverse, and these are some common notations for inverse. We either say sine inverse of x or arc sine, but it basically means the same thing, sine inverse. The sine inverse exists in the first quadrant and the fourth quadrant. And there's a reason why it only exists in two quadrants. And notice there's a difference between if the sine is in the first quadrant and in the fourth quadrant. Think about it. If the sine's in the first quadrant, you know that it's positive. If the sine's in the fourth quadrant, you know it's negative. So that's how you know where the sine inverse is if the value you're looking at is positive, then it's in the first quadrant. If it's negative, it'll be in the fourth quadrant. And we'll look at that some more, but we limit it to two quadrants because it needs to graphically pass the horizontal line test to exist. And also we choose these two quadrants here because one of them's negative, one of them's positive, so therefore you know which one it's in. Whereas if I would have chosen the first and second quadrant up here, even if it doesn't pass the horizontal line test, let's say you use the first and second quadrant, they're both positive, so you'd have no idea which one you're talking about. So in this case, we are going to use first and fourth because if it's a positive value, you know it's in the first, negative, it's in the fourth. So for example, if I want to find the exact value of sine inverse, and remember, when you're finding sine inverse, or any inverse trig function, what are you finding? You are finding, and if you guessed it, an angle. So basically this is asking you the reverse. It's saying what angle creates a ratio of square root of 2 over 2. And so if you want to think about it, remember, if it's positive, this means this is in the first quadrant. And remember, anytime it's square root of 2 over 2, it used to be 1 over the square root of 2, and then we reduced it. Or, sorry, not reduced it, but rationalized it. So remember, sine is opposite over hypotenuse. So opposite's 1, hypotenuse square root of 2. Well, what type of triangle gives us square root of 2 and 1 for the opposite and hypotenuse? And remember, if you guessed 45, 45, 90, you're correct, because remember, it's 1, 1, square root of 2, whereas 30, 60, 90, the 1's opposite the 30, the square root of 3 is 60, hypotenuse 2. So you know this is a 45-degree angle, and remember 45 degrees in radians is pi over 4. So the answer to the question of what angle has a sine of square root of 2 over 2, or sine inverse square root of 2 over 2, it would be pi over 4. So if I asked what is the sine inverse of square root of 3 over 2, you know it's in the first quadrant. And you know the opposite is square root of 3, the hypotenuse is 2. So you know this is a 30, 60, 90, which means that this is 60 degrees, and 60 degrees in radians is pi over 3. So that would be your answer. Now, if it's a negative value, then you know it's in the fourth quadrant. The hypotenuse is 2, the opposite square root of 3, because remember we're trying to find that angle. And since we know that this is 60, because it's opposite the square root of 3, but if it's in the fourth quadrant going this way, it's actually a negative 60 degrees, which means it's a negative pi over 3. Now let's look at the inverse cosine, and it's the same deal, where if you look at it over the entirety of the graph, it does not pass the horizontal line test. But if we restrict it to 2 quadrants, and we start here at 0, and restrict it to right there ending at pi, notice now we could find the inverse of just that part. And if it goes between 0 and pi, looking on a graph here, 0, pi over 2, and pi, that would be the first and second quadrant. And notice here by the graph, cosine's positive in the first, but negative in the second. So cosine inverse exists in quadrant 1, and that's where it's positive, and quadrant 2, that's where it's negative. So if I'm asking you to find the cosine inverse of 1/2, that would be in quadrant 1. We're trying to find this angle. Cosine, remember, is adjacent in hypotenuse, or x over r. So we know it's a 30, 60, 90, because the hypotenuse is 2. So that basically means that this angle here is 30, which means this is 60, and 60 degrees is equal to pi over 3. If I asked you to find negative square root of 2 over 2, remember, anytime it's square root of 2 over 2, like this, that means it was 1 over the square root of 2 originally, before you rationalized it. Because anytime the number under the square root and the fractional denominator are the same, that's how you know you had to rationalize it. There's a difference between square root of 3 over 2, because that is not the same as that. That is why you didn't have to rationalize it. Whereas square root of 2 over 2, you rationalize to get that. So 1 over the square root of 2, it's negative, which means it goes in the second quadrant. So you have negative 1 and square root of 2. And that means that this here is 30, which means this is 60. However, now we're finding the angles in the second quadrant. We have to find from here all the way to there. So basically, we know that this angle is 120 degrees to get there, because if it went all the way to the line, it would be 180, and since the space there is 60, 180 minus 60 gives you 120. And when you change it to radians, 120, or actually not 120, sorry, I made a mistake. If it's 1 and the square root of 2, these angles should be 45 and 45. Hopefully you caught that and were like, what the heck are you doing? So these two angles are 45 and 45, because remember the ratios of 45, 45, 90 are 1, 1, the square root of 2. So 180 minus 45 is 135, and 135 in radians is 3 pi over 4. And you could just change it to radians by multiplying by pi over 180. Then we have the tangent inverse. And if you look at the tangent inverse, we have to use a part that's not interrupted by an asymptote, because an asymptote means that the graph doesn't continue, and therefore it wouldn't have an inverse. So in order to do that, we have to look at the part that's between two asymptotes, which is this part right here. So that's why the domain is restricted to negative pi over 2 and positive pi over 2. Because if we go any further, then we run into the asymptote. So basically, the tangent inverse exists in quadrant 1 and quadrant 3. Quadrant 4. In quadrant 1 it's positive, in quadrant 4 it's negative. So it's the same quadrants as the sine inverse. So finding the tangent inverse of square root of 3, you know it's in the first quadrant. And remember, tangent's opposite over adjacent, so it's square root of 3 and 1. So that means this is 60, and 60 degrees is equal to pi over 3. If I asked you to find the tangent inverse of negative 1, well, negative 1's in the fourth quadrant, and that means you have y over x, and remember in the fourth quadrant y is negative. But basically, which special right triangle would have the two legs be 1, and that is a 45, 45, 90, which means if it's in the fourth quadrant, it's actually a negative 45 degrees, which means it's negative pi over 4. Now, there are a couple other types of questions that you might have. For example, finding the exact value of a composition. Where it says cosine of sine inverse of 4/5. And here's how you do these compositions. The first thing you want to do is work inside out. What I mean by that is draw sine inverse of 4/5. And remember, since it's positive, what quadrant are we going to draw the picture? You guessed it, first quadrant. And based upon this angle, the opposite is 4, hypotenuse is 5. So now we have a picture for this problem. Now, the second step is to find, in this case, the cosine of this angle. Well, in order to find the cosine of this picture, whoops, went too far, we have to find the x here. Well, in order to find the x, what do? You guessed it, Pythagorean theorem. So x squared plus 4 squared is equal to 5 squared. So x squared plus 16 equals 25. X squared equals 9. And x equals 3. So then if you want to find the cosine of that picture, the cosine, remember, is adjacent and hypotenuse. So the cosine is equal to 3/5. And that is the answer. So the cosine of the sine inverse of 4/5 would equal 3/5. All right, any questions, please feel free to ask in class. Don't forget to do the questions and to take your notes. All right, have a good evening.